And this is going to be a little bit of an additional lecture. I'm probably not going to be asking some of these questions on problem sets or exams, but it's fun to know either way. So one of the cool things about covalent, one of the many cool things about covalent bonding is covalent hybridization. So covalent bonding is very directional, but ionic bonding is non-directional. But anyway. But covalent bonding could also do this hybridization, which is combining essentially these two or more atomic orbitals, which will cause this kind of overlap, these orbitals. The best example is Sp3 hybridization for a fully saturated carbon-carbon bond, CH4. So let's go ahead and look at these examples. So let's go ahead and click down to this page. So for Sp3 hybridization, you have kind of your typical, you have this ground state, so right here. So you have 2 electrons, Pauli exclusion principle, in your 2s orbitals, 2 in your 2p orbitals. One of those electrons from the s orbital is promoted into the 2p orbital. So it jumps up into here, as you can see right here. So this is the excited state. And eventually, you're going to kind of see that those electrons, once they get, the kind of procedure for this is, actually, where is it? Let's go ahead and look over here. So we have one electron that's promoted to from the 2s to the 2p, and then the remaining 2s orbital will mix with the other 2p orbitals. So you're going to have 4 sp3 orbitals for carbon. So again, that's kind of the critical idea, and that's when we're kind of bonding with that fully saturated carbon. So you'll have 4 sp3 orbitals. So again, 3p, 1s combined hybrid. You can also have sp2 hybridization. So again, same ground state, same kind of excitation here, but here you're going to have essentially goes into this excited state, and then you'll have 3 sp2 orbitals and 1 2p orbital. Again, let's go ahead and backtrack on this. So in sp2 hybridization, 2s promoted to the 2p mixes with 2 of the p orbitals. The remaining p orbital remains unhybridized. So, and it's denoted as pz. So sp2 orbital will form a trigonal planar structure as opposed to the tetrahedral. We're going to get into structural versus bondings in the next video, and then into. Thanks. I'll see you next time.